Hi teacher, this is one of the problems that we did in a quiz. It's the one that says that a piece of aluminium and a piece of copper are dropped into a bucket with water. So we're gonna start by seeing what data do we have. And the problem is telling us the mass of the copper, the mass of the water, and the mass of the aluminium. As well the initial temperature of the three, and well, another thing that I had to check in the book was the specific heat of each one. So the problem is asking us the final temperature or the equilibrium temperature of of the mixture. So what we have to do is to add the heat of each one of these, and this is the heat of the water plus the heat of the copper plus the heat of the aluminum. And this at the same time is equal to the specific heat times the mass times the difference in temperature. And it's the same for the three. Well, and after making like a lot of problems, I realized that the equation to find the equilibrium temperature of a mixture is always the same, and it's this. It's always like the specific heat times the mass times the initial temperature plus the specific heat of the other thing. And this is divided. This is for the copper, this is for the water, and this is for the aluminum. And it's divided into the specific heat times the mass of the copper plus the specific heat times the mass of the water plus the specific heat times the mass of the aluminum. It's always the same, and what makes if this is a plus or a minus is the initial temperature. For example, here I turn every temperature into Celsius because for me Kelvin are like kind of difficult to know if it's cold or hot. So transforming the temperature into Celsius, it's like more easier for me to know if the system is going to get hotter or colder. So this is so the sign here is given by the initial temperature. For example, here the initial temperature is minus 73.15. So we know that the aluminum is going to get colder the system. And for example, the copper, it's like very hot. So maybe the equilibrium point is going to be like in 5 degrees Celsius. So now that we have this equation, we just have to substitute. This is the specific heat of the copper. This part is from the copper. This is from the water. And this is from the aluminum. As well in this, copper, water, and the aluminum. And the final temperature is going to be the same for every part of the system because it's in equilibrium. So I just solved this, and what I obtained is that the equilibrium point of the system is going to be at 9.46 degrees